Alright, today we're graphing linear equations. Okay, this is what you need to know. When I talk about standard form, this is standard form. AX plus BY is equal to C. Okay, X and Y are okay, well, you'll see here in a minute. Okay, I'll explain in a minute. For standard form to be a linear equation, A has to be greater than or equal to 0. And A and B cannot be 0 at the same time. Alright? So A can be 0, but B cannot be if A is 0. If A is not 0, then B can be 0. Okay? A and B cannot be 0 at the same time. They are not both 0. Everybody understand? So I look at the problem below. We have 3x plus 2y equals 5. It is in standard form because x and y are on the same side. I determine if it's linear by looking at A. Is A greater than or equal to 0? Is 3 greater than or equal to 0? Yes. Is A and B not 0 at the same time? A is 3, B is 2, so they're not 0 at the same time. This is a linear equation. Alright? Any questions on that? Write down these 4 equations, and we're going to determine if they are linear or not. Alright. So what we do is we have y equals 4 minus 3x. Before we can figure out if it's a linear equation, we need to write it in standard form. So I have to get x and y on the same side. So should I move y or should I move x? I need to move x because remember A has to be positive. So I add 3x to both sides. So now I have 3x plus y is equal to 4. Is this standard form? Yes, x and y are on the same side. So then I identify whether or not it's a linear equation. So I look at A. Okay, is A greater than or equal to 0? Greater than. Is A and B, which B would be an understood one, are they 0 at the same time? No. Okay, and then the other one is if A, B, and C all have a greatest common factor 1, which in this case they do. So this one is yes, it's a linear equation.
So if it has 2 no's, then it's a no?
If it has 1 no, it's a no.
What if it has 1 no then? Because of the 1 y. How do you
No, it like,
if it's a yes?
or meaning, okay, well, sorry. Is A greater than or equal to 0? That's a yes. Okay. A and B 0 at the same time needs to be a no.
Okay.
Sorry. Okay. Or you could say, are A and B both not 0? And you could say, yeah. Okay. All right. Just they can't be 0 at the same time. All right. So this would be yes. All right. We have 6x minus xy equals 4. Okay. Is this written in standard form where x and y are on the same side? Yes. Okay. But is this a linear equation? No, because you can't have 2 variables like this. You need x. You need the x by itself and y by itself. Okay, so this is a no. Okay, because b cannot be a variable. Okay, b has to be an understood number. Okay, you can't have 2 variables. Any questions there?
So whenever it's like that, it's always going to be a no?
That would be a no. Okay, this x needs to be a number. If that was this, it would be a yes, right? Okay. Y equals x2 minus 4. Okay, is this standard form? No. So I could move it around, right? But I can just look at it and tell, is this a linear equation? No, because I can't have an x squared. Remember, it's ax plus by equals c. Okay, did I ever say it could be x squared? No. Okay, so this is a no without even have to move it in standard form. Okay, it is a no. Okay, any questions?
The square
All right, what you need to know, the x-intercept is the x-coordinate in which the graph of the equation crosses the x-axis. So where does the graph or the line intercept the x-axis? That's where we call the x-intercept. The y-intercept is the y-coordinate where it crosses the y-axis. Okay? So where does it cross the y? That's the y-intercept. All right. Just look at this. You don't have to write it down. My x-intercept, where does it cross the x-axis at? What coordinate does it cross the x-axis at? -3. Where does it cross the y-axis at? 4. Okay? So today you'll have to identify x and y intercepts. All it is looking at a graph and seeing that it crosses the x at -3, it crosses the y at +4. All right, any questions on that? What about this one? What's the x-intercept here? 0 would be right here at the origin. Does it cross at the origin? No. So what's my x-intercept? My x-intercept? None. Okay, it does not cross. Where's my y-intercept? 6. An equation that looks like this, that right there, y equals 6. Because my x changes, right? It's here it's at 1, here it's at 2, here's at 3. But does my y-intercept ever change? Does my y-coordinate ever change? No. So we write an equation like this, y equals 6. Okay? Yeah, I don't think you need to know that yet, but just so you know. A horizontal line is y equals a number. Okay? Alright, write this down. To find x-intercept, let y equal 0, okay? So if I want to know where my x-intercept is, where it crosses the x, then I let y equal 0. Because if you think about a graph, okay, if it crosses right here, what's my y-coordinate of this point? What would be my y-coordinate? Let's say my x is 3. What would be my y-coordinate? You said it. 0. Okay? So what I do is I plug 0 in here, and I find what my x equals. So 2x equals 16, because 4 times 0 is 0. So it gets rid of 4. What is 2x equals 16? X equals 8. So for this graph, okay, if I was to graph it, it would cross the x-axis at 8, because that's a coordinate 8, 0. So if I want to find the y-intercept, what do you think I do? Make x 0, right? If I want to find x, I make y 0. If I want to find y, I make x 0. So write this down. So I need to make x 0. So 2 times 0 is 0. So I don't even write that. 4y is equal to 16. Divide by 4. So what does y equal? Y equals 4. All right? All right, you don't have to write this down. Just listen. Okay, as I was saying earlier with the horizontal line, okay, y is equal to the y-intercept, what's the y-intercept here on this one, this horizontal line? 5. So you would see y equals 5. If it says graph it, you just draw a horizontal line at 5, okay, because the x-coordinate changes but my y-coordinate doesn't. It's the same thing for this vertical line, okay, where x equals a number. What is the number here? 5, okay, because my x-coordinate doesn't change and my y does, okay, so we just say x equals that number. All right, any questions? All right, your problems might look like this. It says graph by making a table. All right, so we have x here, we have y here, okay, and then my table, what's in here is 1/3 x plus 2. What we do is we just pick some numbers. I'm going to let you pick 4 numbers. Okay, I'm going to go with -3. I'm going to go with 0. I'm going to go with 3, and I'm going to go with 6. And you'll see why I pick those numbers later. Okay, what I do is I plug those in for x and see what my y equals. So -3 times 1/3 is -1. What's -1 plus 2? 1. 0 times 1/3 is 0. 0 plus 2 is 2. 1/3 of 3 is what? 1. 1 plus 2 is 3. What's 1/3 of 6? What's 6 divided by 3? 2. 2 plus 2 is 4. Alright, so now I could graph this. Okay, if they gave me a graph, I plug in my x coordinates, I plug in my y, and I now like this. Okay, so my x, I said -3 was my y coordinate when x was -3. Okay, it was 1. When x was 0, what was my y coordinate? When x was 3, my y coordinate was 3. And when x was 6, what was my y coordinate? 4. Okay, is that a straight line? Okay, it should be. Okay, I just can't draw. Okay, this is a linear equation. Alright, this is what it looks like. Does anyone know why I picked my x's the way I did? They came out evenly, right? If I had picked 1, right, 1/3 of 1 is 1/3. 1/3 plus 2 is 2 1/3. Do I really want to graph that? No, it's right there. Okay, what's easier to graph? Whole numbers, right? Okay, so you can see why I picked those numbers. Okay, I've been doing it a while, so it was easy for me. You may have to stare at it for a little bit. If not, you can just pick a number, okay? And if you get 2/3, then go 2/3 in between those numbers, all right? No big deal. All right, here's your homework.